Hi, Ms. Sobek. Okay, so let's start with parabens, and the scientific name is methylparaben. First, we'll start with the structure and the bonding. Parabens form this small colorless crystal or white crystalline powder with practically no odor and no taste. Its formula is C8H8O3, and this is its 3D shape. Its boiling point is very high, and it's 275 Celsius. Its melting point is 131 Celsius, and it's very important to note that it's slightly soluble in water, almost insoluble, and it's very, very highly soluble in ethanol. But as its chain grows longer, it becomes even more insoluble in water and less soluble in ethanol. This compound has a polar and a nonpolar end. This CH3 end is the nonpolar end. Sorry, not this. That's the CH3 end. It's nonpolar, and this end is the OH, is the polar end. And this is very important to know because studies have indicated that methylparaben, when applied to skin, can react and cause the skin to be very sensitive to UV rays and like sunlight rays. And it is proved to be carcinogenic, but for some reason still not banned here. Yeah. So right here we can go on to the organic chemistry part. We have the formation of methylparaben. It's formed from the 4-hydroxybenzoic acid plus methanol. And with these two, it's gonna make methyl 4-hydroxybenzoate. This is the organic structure, and it's worth noting that the methylparaben is a 4-hydroxybenzoate ester, resulting from the formal condensation, which means that there's going to be a byproduct of H2O, of the carboxy group of 4-hydroxybenzoic acid and methanol. So it is naturally found, but it is mostly manufactured in a lab because it's easier to manufacture rather than go out and actually get it. So this methylparaben is used in a lot of cosmetics like foundations, concealers, eyeshadows, other stuff like that. It's biodegradable, which is good. Biodegradable means it's going to break down in the natural environment because it is in fact an organic compound. Let's go on to the electrochemistry. Again, when exposed to strong sunlight, it causes oxidative DNA damage, which means that it might be carcinogenic to the skin. And when methylparaben was exposed in a study to irradiation, it produced byproducts that suggested that reactive oxygen species generated by the redox cycle cause harmful effects on the skin. When the methylparabens were on the skin, when it was exposed to the strong sunlight, this DNA damage was a result of that. Let's move on to the thermochemistry and rates. The formation of methylparaben is an endothermic reaction. The enthalpy of fusion of methylparaben is 396.6, which is very high. The specific heat capacity is also very high, which causes the high boiling point and melting point of the compound. We'll move on to the chemical equilibrium. So as we see here, there's equilibrium in this reaction, which produces the methylparaben. And if any change, according to, I forgot his name. If a change or external stress is applied to a chemical system at equilibrium, the position of the equilibrium will shift in the direction that reduces the stress. Makes sense. So if, for example, we increase the concentration of methanol, the whole equilibrium would shift to the right side, and then we would have to rebalance all of that. Let's see some careers linked to parabens. So, even though in some nations out there, a lot of parabens are banned. Not here in Canada though, or in the U.S., which is questionable, because they've been linked to breast cancer, skin cancer, decreased sperm count. So it has these horrible effects on the human body, and its use is still supported in Canada, just because of how high of sorry, yeah, just because it's very effective and efficient in being antibacterial. Um, it has to be noted that in the European Union, it is in fact banned, and one of the most like carcinogenic types is phenylparaben, and it is banned in the EU. Thank you.